Alright, again, if you're just showing up, we're still in the 5 minutes. You'll be talking with your partner about homework, filling out your plan book, filling out table of contents, or for me to pass out papers. I just realized I should probably do it. Here, Delaney. You're not here? Dang it. I thought you were Eleanor, Alex. I'm guessing this is Cooper. Try to make sure you have last name on stuff. I'm assuming that's you. Grant. Renal. Emma, Ella, no. Matt, less fun to rhyme with. Eleanor, really tough to make rhymes. Eleanor, Bellanor, Bellanor. Minute left. You could be working on a homework problem for tonight. You checking last night's homework, making sure you're all set to go, doing some deep breathing, stretching your gluteus maximus. I don't know what you're doing. Penelope looked at me like she's not sure what gluteus maximus is. So there's a class. So if you don't know, I work at Lifetime, which I think most know. There's a class at Lifetime called Gluteus Max Out that I am very, very afraid of. Because your gluteus maximus is your butt. And a lot of those classes are like squats and like lower body workouts, and squats hurt me. They hurt me a lot. How was math this morning, guys?
It was great. I'm good.
Great. Is it alright? So we're gonna need to be in pairs. So if you don't have a partner, try to make one. So Alan with Liam. Grant, you may want to, when we do this activity, you might want to talk with Aubrey, and you can stay seated there, but you guys can talk with each other, or Zoe, or the three of you guys can chat maybe. But the situation we're going to talk about deals with a partner, right? Like a little brother, a little sister. We're going to talk about doing the dishes. Nobody ever wants to do the dishes, really.
I'll do it.
I don't like doing the dishes in the winter because my hands are all dry. So, anyone want to read our intro here since we have a little bit of time today? Anyone feel like reading this morning? Hit us with it, Aubrey. When you studied probability.
When you study probability in earlier lessons, you focused on probabilities of single events. For example, one draw of a card or picking one cube from a bag. You also examine probabilities of either one or another events occurring. For example, winning either a raffle ticket or prize on either a team or a queen. In this lesson, we'll begin to investigate which one and another event will occur, such as flipping two coins or spinning a spinner multiple times. Throughout this lesson, we'll use questions to help with this routine discussion.
Nice, thank you. So our big questions: does the result of one event affect the other, and that's affect with an A, affect? And how many possibilities actually are there? Anyone want to read problem 43 for us? Feel like reading? Setting us up and we'll talk 43. Nobody, otherwise you gotta listen to me. Alright, in chapter 1, we met Chris and her older sister Rachel, right? So we got Chris and Rachel, and they've made a system to determine who washes the dishes. So Chris has been washing the dishes much more than she feels is her fair share. So she decides to change the rules. So she proposes that they get 2 coins, and each day she and Rachel take a coin and flip the coin. In comes you and your partner, right? So we're going to talk about you and your partner. So if there's 3 of you, you got to talk about just if there were 2 people flipping a coin. So here's our rules. If the coins match, Chris washes. If the coins don't match, Rachel washes.
Ooh.
Right? So think to yourself for a moment, is that a fair situation? If the coins match, Chris washes. And if they do not match, Rachel washes. Just think for yourself. So Rachel thinks this is a good idea, and her little sister is really silly. She thinks since there are two ways that the coins can match, right? Head and head, tails and tails. That is going to happen more often than the not match, right? Heads and tails. So do you agree with Rachel? I want you guys with your partners to think about these questions. So do we agree with Rachel that Chris is silly and her system isn't going to make sense? Does it matter if they flip the coins at the same time? And you want to write down in your notes like A, B, C, D, and just jot quick little answers for these as you talk with your partners. What are all possible outcomes? Like Chris's coin, Rachel's coin. Remember, they're flipping at the same time. And then look at our list to determine, is Rachel actually right? So I'm going to give you guys a few minutes to talk about this. I'm going to flip my screens around, but you want to determine, is this a fair way to determine who does the dishes? And if not, why? Cool? Questions? So chat with your partners about this. 2 coins flipping at the same time. Have at it. You probably want to have a book open in front of you, because up on the TV this gets smaller. Probably. I want to push your thinking a certain direction. Let's imagine one of them has a quarter, one of them has a nickel. Or one of them has a dime, one of them has a nickel. Just they have 2 different coins. That might help your thinking. Have we talked about this at all? Yeah? Do we agree? Why don't we agree? Okay. Why?
So there's 2 ways for the heads, tails, and tails. And so one way for
Okay, and you disagree with that, Matt?
heads and tails.
Why?
So right. Oh, all of the sheets.
1/4 of the chance to what? Who does? The coin's matching or the coin's not matching? So Chris is going to wash if they match. Okay, either both heads or both tails. Rachel's going to wash if they do not match. So you have to think about how many situations would they not. If you jump to C, I'm not going to give you the answers right now. I'm just going to help you a tiny bit. If you jump to C to look at all possible outcomes, modeling is always a good way to help our brain make sense of this. Chris has a coin Rachel has a coin. Think about what can happen to Chris's coin and Rachel's coin and how many different ways it can actually happen. So if it's a normal coin, what could Chris's results be? Heads or tails, right? So if Chris gets heads, what could Rachel get? Or so there would be two different results for Chris getting heads. So think about that. Even when Chris gets heads, Rachel could get heads or Rachel could get tails. So this is not a complete table, but I would make a table or something like that to help you visualize how many options there really are. Again, if you want colored pencils, highlighters, anything like that, come up and grab it.
Maybe Rudolph, please come to the office. Maybe Rudolph, please come to the office. Thank you.
You are talking with your partners to try to work through these problems. You don't have to write everything down right now. So if you're taking your time writing right now, I'd rather you be discussing. We'll take time to write here in a minute. So discuss through these. Like, does it matter if they flip at the same time? Or if Chris flips first, will that affect Rachel's flip? If we work through part C, how many actual results could there be? And then is it fair? So I'll give you about 2 more minutes to talk about this. By the way, with part A, Rachel thinks this is not fair. So with answering, do you agree with Rachel? Rachel thinks this is not fair and that she has an advantage, that her sister is going to do the dishes more than her. I disagree with Rachel. Every point has that test. All right, let's bring this conversation together. I disagree with Rachel, but I've been known to be wrong before. Can anyone talk to me about whether you think this is fair or not? We won't even talk about whether we agree or disagree with Rachel because that doesn't matter as much as what we think. Elaine?
I think it's still fair only because you can get heads and tails, and then you could, like, 2 pairs of heads and 2 pairs of tails, and then you could get heads and tails and then tails and heads.
Ooh, so you're saying heads and tails is not the same thing as tails and heads? Because if Chris gets heads and Rachel gets tails, is that the same as Chris getting tails and Rachel getting heads? These are 2 different situations. Even though it is the not match, heads, tails is not matching, well, tails, heads is different. Imagine if Chris has a quarter and Rachel has a dime. Heads on the quarter, tails on the dime. Tails on the quarter, heads on the dime, 2 different things. And then what other situation have I not listed out here? There's one more, Alex.
Tails and tails.
Tails and tails. Both the quarter and the dime get tails and tails. So Rachel's wrong. This is fair. So please notate somewhere on your notes that this is fair. There are 2 matching situations and 2 non-matching. There are 2 matching heads, heads, tails, tails, and 2 non-matching. Do you have questions about that? Because that's weird. That's confusing. Yeah.
So if they were using a different formula, would it change anything? That was just to help us.
Even if they're each using a penny, your penny is different than my penny. So let's say that we're each using a penny, and you flip this penny, and you get a heads, right? I flip my penny, I get a tails. You flip again, you get a tails. I flip, I get a heads. Were those the same things? No. Both of them were non-match, but they weren't the same thing. I don't know why I threw that out. I thought we were going to actually flip, but then I can't make what happen what I want to happen. We could be here all day, because we could just end up matching and matching and matching. By the way, we can test this on our calculators like we were doing yesterday with running simulations. I'll show you guys how to do that later in the year. You can have your calculator flip the coins for you, so they have probability simulations. So for C, please make sure you have some kind of table like this showing that there are 4 different options. Heads, 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 tails, tails, heads, tails, tails. B was, does it matter if they flip at the same time? Anybody have thoughts on whether it matters if they flip at the same time? Like, so let's say I play this game with Patrick. Patrick flips his coin first. Can that affect what I get when I flip my coin? No. Right? Like, I can't flip it just a certain way, or like it would be great if we could, right? You could like win a lot of money or something, get a weighted coin. But no, I can't modify based off what Patrick does just because he goes first. So please skip down a little bit in your notes. And so the quick answer for B is no, it does not matter. Because these events, and here's where we need an important vocab word, so I would underline this, are what we call independent. Independent events. And what that means what's it mean to be independent? Right? Yeah, you take care of yourself. Do you rely on anybody else? No. So one event does not affect the other. We're going to make this real short. One does not, I would write that big, underline it something, affect the other. Independent just means one does not affect the other. If you want a more formal definition, flip your page, and in the math notes box, it defines, or I guess flip your page twice, independent and dependent events. So if you look at page 266, there's your formal definitions on 266, independent and dependent. The easy way to remember independent, one does not affect or impact the other. So if we just want to hit both important vocab words right now, then, what do you think it means to be dependent? Ella? Yeah! The events affect each other. So we can say one does affect the other. When we talked about this last week with our deck of cards, anyone remember that situation where one event would impact the next event? So you really haven't missed much, Allie. These vocab words are the big important thing you need to get down. We were working with decks of cards last week. Anyone remember what I did that would have impacted? Marvin? Yeah, if I keep the card out of the deck, right? I was shuffling and I drew an ace. We were looking at what's the probability of an ace. And if I keep the ace out of the deck and I go to get another ace, now I have less. But I got less aces left in my deck. What would make it independent? What did we do so that the first draw did not impact?
You put the card back in the pile.
Put the card back. And that's exactly what your book will tell you. So if you're on the homework and you're confused, flip to 622 right here. It talks about the cards. It says independent if you draw a card and put it back. Dependent if you draw a card and keep it out. Anyone think of a game that you guys might play with each other where if you didn't do it at the same time, like we just said, flipping the coins at the same time doesn't matter. Patrick can flip his and then I flip mine. What game do you guys play with each other sometimes? You might do it with your siblings, so like, oh, I don't want to do this and neither do you. Let's play this to determine who has to do it. Where if one person goes ahead of the other person, it's totally not fair. Delaney, you've been waiting.
Rock, paper, scissors.
Why?
Because, like,
Aubrey?
If someone goes before you, you can beat them.
All right, so let's play rock, paper, scissors, right? All right. Rock, paper, scissors, shoot. Is it fair if I wait until after Aubrey throws hers? No, so let's play again. So go on shoot, right? Rock, paper, scissors, shoot. Rock, paper, scissors. Ah! If you wait, it's not like, that would not be fair at all. Like, oh, hold on, let me. And there's actually rock, paper, scissors competitions, by the way, if you've ever been curious about that. So, flipping coins. Hold up. If Aubrey and I flip coins and she flips her coin and I wait and then I flip my, it doesn't matter. But if we're playing rock, paper, scissors, I'm totally a cheater if I wait. And Aubrey just probably wouldn't then play with me. And, I mean, or she's going to lose because if I get to go second, I'm going to choose what makes me win. So independent, like flipping coins. Dependent, like rock, paper, scissors, if you wait. But if you do it at the same time, it's not, it's not dependent because I don't know. So let's make sure we wrap this up. So our list from part C, please make sure that you have this table showing the 4 different outcomes. And then an E is Rachel right. Rachel said this is not fair. No, she's wrong. This is fair. Her sister made up a fair method for determining who does the dishes. 2 matching coin situations, 2 non-matching coin situations. Any questions on this? Let's look at our rock, paper, scissors problem. So we already kind of gave this away a little bit, talking about independent versus dependent. So I hope you guys know how to play rock, paper, scissors. Let's move on to a new page. Let's do this, because we already talked about independent versus dependent. So I want you guys to make a table on your paper. And let's make this table just so that we all have the same table. Me and my partner. Right? Whoever your partner is. Doesn't matter. You don't have to write their name. You could literally write partner or teammate or whatever. We're going to play rock, paper, scissors. So we're on 544 for those of you who have really good notes. This is 544. I want you to list out every possible game result when you and your partner play rock, paper, scissors. Just like we had with the coin flips. Well, there's only heads or tails. There's only 2 results, but there's a lot more than 2 outcomes when we play. So think about, if I throw rock, what could my partner throw? Is there only one situation where I can throw a rock, or are there multiple where I throw a rock and they might throw something else? Now you can't have, if I have rock here and rock here, I can't use that again, because that will be the same. It's like heads and heads again. Even though it's two different people, rock and rock is the same. So I can't use rock and rock again. So that is one possibility. What happens if we both throw a rock? We tie and we go again. Right? So there's one possibility. I started your table for you. You and your partner try to determine how many total outcomes are. There's more than 3. I'll tell you that. There's more than 3. All right, have at it.
Let's do scissors and scissors. Where does scissors and rock?
Ooh, you gotta list these separately. So you can't list out like that. Like each line is one. If yours is different, yeah, but you can't use rock and rock. So if you throw a rock and he throws a rock, there's your rock situation. But could you throw a rock and he throws something else? So we gotta list those situations. So, match, get all those first. So how many situations do you have there? You went on a new page. So many situations. Nice, that vertical. I love vertical. Oh, such a good place. Oh. All right, who can help me out? And I'm gonna start saying I like stay consistent. I keep trying the same thing, so I'm gonna try rock over and over, and like I'm gonna keep with rock for a minute. Who can help me fill out my table? Alex? So what do you want to put next? Sure, they changed their throw. I stick with rock. What next? So there are 3 outcomes where I'm throwing rock. We match, we rock paper, and we rock scissors. So tie, who wins here? Partner, paper, right? Who wins here? Rock. So we've got tie, they win, I win. Okay. But so then I decide, well, maybe rock is not the only thing I should be playing. So what next? You can keep helping me, Kate.
Scissors and scissors.
Okay, another tie.
Scissors and paper.
Okay.
And scissors and rock.
Okay, so tie, I win, they win, right? So another those situations. Okay, who can help me now? Allie? Okay, so now I play paper. Paper, paper, we tie. Paper, scissors, and paper, rock. Did I repeat any event happening twice? Like, did I use rock, rock twice, or me, rock? Did I use rock, paper twice? No, right? I used rock, paper up here, and then I used paper, rock, but those are 2 different things, right? Just like heads, tails versus tails, heads, 2 different things. Paper, rock versus rock, paper, 2 different things. So how many possible outcomes do I have? 9. 9 possible outcomes. I'm noticing something interesting here. When we had coins and when we had 2 possible outcomes, like two things that could happen, we ended up with 4 possible game results. Now that we have 3 choices, we ended up with 9. What if we had 4 choices? Like rock, paper, scissors, Spock. Right? Anyone ever seen the giant rock, paper, scissors, lizard Spock? So what if we played with 4 options or 5 options? We're not going to answer that right now, but think about it. If 2 gave us 4 game results, 3 options gave us 9 game results, how many do you think 4 or 5? We're not going to answer that. Just think. Just put it in your brain. All right, moving on. So let's talk about simulations. Right? So we're going to be on 46. I'll drag this down for a minute to get us started. So you and your partner are going to play rock, paper, scissors. Right? M and P, or player A, player B, however you want to do it. Excuse me, you're going to play a dozen times. Not actually. We're going to do this. What is it called? We talked about this yesterday. When we don't actually do it. Theoretical. Jeez, Martin. Theoretical. I didn't even finish the question. So when you don't actually do it, but you think about it, or we think it through that TH, think, is theoretical. So this is going to be theoretical. You're not actually going to play. It's how many times would you expect. So if you need, go back to your table and look at like, okay, player A, player B, count the amount of wins versus losses versus ties, and then use that to anticipate out of 12 times playing, how many times would you expect player A to win, player B to win? How many times would you expect that they tie? So think that through. I'm not going to answer this question for you yet, but we're going to get some information together. We know that the probability of something is what we want over our total. Right, so if I look at the probability of me winning, which is going to be your M, your me column. How many total possible outcomes are there here? We talked about this. 9, right? We got the list. We got 9. Sweet. We know that 9 has to go on the bottom. That should be the easy part, determining your denominator. The numerator, you got to think a bit more. We got to know how many of these situations do I win. Grant?
3. 3 of them tie, 3 of them the partner wins.
So I go up through, I highlighted on here, right? 3 of them are ties, there's no highlighting. 3 of them, the partner wins, and 3 of them, I win. That rock, that scissors, and that paper. So I win 3 out of the 9 times. Can that be simpler than it is right now? Ooh, yeah? A third. I can divide by 3 on top, divide by 3 on bottom, and we have a third chance of winning. And likewise, we have a third chance of losing and a third chance of tying. Exactly. Every outcome is equally likely here. Which makes this fair, right? Because we don't know what our partner is going to throw. So if we have a third chance, how does that tie to our 12 times? Can you help me out with this? We're going to play the game 12 times. How many times do I think I'm going to win? If you don't know how to calculate this yet, please write this with me. Expected outcomes. So this is how we calculate expected. It's what we expect, not what actually happened, not what will happen. It's what we expect based off the math. Expected outcomes. Yeah, I got really messy. To calculate this, all we do is take the probability of that event, whatever it is we're talking about, and multiply it by the number of trials. And trials is just a fancy word for times. How many times do we do it? Every time you start over, that's a new trial. So like every time you die in the game and it resets you back to the checkpoint, that's a new trial. How many trials are we doing here? 12, right? We're going to play it 12 times. What was our probability? Ooh. What was that fraction that we just had? Our probability? A third, right? So to calculate this, we're going to say, like, my expected wins. Oh, come on. Grab this. Is going to be my probability of 1/3 times the 12. What's a third of 12?
4.
Ooh, 4. Careful. Just 4. If we made the 12 a fraction, 12 over 1, we'd then have 12 over 3, which comes out to be. I love your Bob Ross shirt, by the way. Bob Ross is a great guy. Bob Ross is the guy with the paint, and he's going to make a happy tree and a happy cloud, and everything's happy. Questions on how we calculate the expected outcome? Take the probability of what you want, multiply by how many times you get to do it. So what if, hang on to your brain, what if we played this 20 times? Is that as easy as 12? Why? Alex, why would 20 not be as easy as 12? 20 is not easily divisible by 3, right? So if we did a third of 20, we'd actually get just under 7. It'd be like 6.6.
Yeah, I got 6.666.
That 7's a lie. Don't trust the 7. That's your calculator lying to you.
Okay.
It rounded, but don't trust it.
Okay.
All right, so realize they gave you a number to be easy intentionally. So some numbers will work out easy. Other numbers will not work out as easy, and that's okay. So now we got to talk about whether things are independent or dependent. So I need you and your partner to discuss this first for a couple minutes. We got about 4 minutes left. Are these situations independent of each other, or are they dependent? Does one affect the other? So think these through. Take a couple minutes. Excuse me, on your own. You can just label these I or D. If you want to have good label, you can do like IN or DEP. Independent or dependent. We use cards on this. Should have been using cards more. for the sake of time. Renaud, what do you think? Flipping a heads and then flipping another heads. Is that independent or dependent? Independent. Why? Yeah, my first flip the coin, get heads, great, flip the coin. My first flip has nothing to do with my second flip. It literally can't. Now, what about choose a jack from a standard deck of cards, Alan, not putting it back in the deck, and then choosing a king? Why?
Because
the question is, are you impacting the second probability? So did this impact the second probability?
yeah.
Why?
Because you didn't put the card back.
Yeah. By not putting it back, we've now changed the denominator. Right? The number of cards in the deck is now different. That's not okay. That impacts it. That changes. That's dependent. Grant, what about if we pick a blue marble from the bag of marble, put it back, and then pick a blue marble again? Independent because we didn't change anything. We put it back. And Liam, what about rolling a 6 on a number cube 3 times in a row?
Independent.
That is independent because my first roll will not impact my second roll or my third roll. That is independent. Any questions on independent versus dependent? So other situations as you pack up that you might think about, what's the probability of going to the park? Is that independent or dependent on the weather? Well, that's probably dependent, unless your parents don't care about the weather and then you're just going or not going. But what's the probability of getting ice cream? Is that independent or dependent on your behavior? What's the probability of so all these things, so it's dependent on your mom's mood, right? So all these situations you can think through. Have a great day, guys. Please try the homework. Let me know if you have questions. What? That's dependent on is it locked. Is there a chain and a padlock? If so, your probability might go down.